Hey, Derek here. So I've been messing with this ore for a while. You've probably seen it on some of my other videos. And it assays really well, but I just can't figure out the recovery. So I'm going to do a little experiment with it and put it in this video. So first, I'll shut this off and show you the kind of ore pile type, the pile three, I don't know, the different types of quartz that you'll see in it. And I'm gonna mix them all up into one sample for this test. So I'm going to pause it real quick and start it and show you what I got. Okay, I'm going to use my phone because it does better at close-ups. So you get some like this. It's just white quartz with a lot of sulfides in it. You can see that, some pyrite, pyrrhotite. There's some copper sulfides in some of this. So that's part of it. I haven't really seen any ratio where there's more or less of one type or the other, but probably more of this type of this altered stuff. It's got some oxidized area. It's pretty altered. You'll see some kind of green tint to there. It's got a lot of sulfides. And then you'll see some stuff like this. It's just really oxidized, kind of vuggy. You'll still see some sulfides in it, but definitely less. And then here's some more altered stuff. Highly altered, crumbly. You can see a pocket of sulfides right there, and it has a lot of sulfides in it, just a variety. I don't know the exact of it. It's just got a variety of sulfides. So I'm gonna take this sample here, these pieces, I'm gonna crush them all up, mix it all up for my sample, kind of explain what I have in mind as we go. So there it is. Okay, I got my sample pretty well dried out. I'm gonna have to hand crush here in my hand crusher. It's starting to rain, so I might move it inside, but I'll get started here real quick. Okay, so I got in a little bit of a hurry to start to rain. I got inside now. So my goal is to crush this all down to 50 mesh. I'm going to fire assay a sample. Then I'm going to weigh out 1 pound, and I'm going to pan it down. And then I'm going to smelt those concentrates. In the tailings, I'm going to take the muddy water, I'm going to keep it, I'm going to dump it through a filter to capture, I suspect there might be some micron gold floating. So I'm going to assay that separate with the filter stuff and the tailings and try to figure out where I'm losing this gold. So anyway, I'm going to get back to crushing and we'll check in a minute. Okay, I got it fairly uniformly crushed. We'll screen that off, see if I can get a little over a pound. Hopefully for my sample. So we'll dump that through a series of screen, trying to get the minus 50 mesh. See how it goes. Okay, let's see if I can explain this fire assay math. I'm not a very good teacher, but so a short ton, 2,000 pounds equals 29,166 ounces. So we weigh out 29,166 milligrams, which is 29.166 grams. So when we assay, melt that down, and recover a little gold bead, for every 1 milligram of gold that we recover equals 1 ounce per short ton, 2,000 pounds. So someone who's better at explaining all of this, go to 911metallurgist.com. Great resource. So anyway, here's my 29.166 grams for the fire assay out of that thoroughly mixed sample. And here is my 1 pound. I'm going to pan that down, and we'll smelt the concentrates, and then we'll assay the tailings and the filtered muddy water to see if there's any gold in there. So see how it goes. It'll be interesting. Okay, got 2 clean things of water here. You want to be dirty, want to be clean for the final. I'm going to do half of it at a time. I'll use this big one for the muddy. I'm going to stop and start so I can speed this up. Okay, now I'm going to dump this panning water through a filter. I'm going to keep all the actual panning tailings, that stuff that doesn't float. This is the muddy one, so this is where I would guess any floating gold would be. Water has a surfactant in it, so I'll add a little more so you see some stuff trying to float a little bit. This is the stuff that would just get flushed away in my wastewater. So I'm trying to see if there's gold in it that I'm throwing out. So I will dry out these tailings, let that sit. I have to empty that bucket and see what we come up with. Okay, so here's the second half of those 1 pound concentrates panned down. See quite a few sulfides. With the loop, you could probably see some specks of gold up in there. Hard to see with all the sulfides, so we'll get it all smelted down and see what we got. Okay, so we have the pan down concentrates. It was mostly sulfides. I roasted it. Here's the ashed filter from the liquid, so it would have been the floating stuff. Here's the tailings. I dried those out. I'll mix that up thoroughly for an assay of that. And here's just the ore that we will fire assay as well, and see what we get out of all these. I will get this and this weighed, the concentrate and then the filtered one weighed, and see what we get, and show you what we got. Okay, here in this first crucible, I've got the just 1 assay ton of ore, 29.16 grams, with a standard fire assay flux from Legend Mining. In this second one, I have the pan down concentrates in a premixed flux that is similar to the assay flux, but better at dealing with all the sulfides. So that's that. And I had 14.2 grams after roasting of those pan down concentrates. And this one, we have the ashed filter with the material that was in there. It was 4.4 grams. So it's some ashes which don't weigh much, and then the material with just a standard fire assay flux there. And in this last one, I have the tailings with a standard assay flux and 1 assay ton, 29.16 grams. So we will get those all in the furnace and cook them up. Okay, how did it spill? The ash filter one, pretty sure I got it all. Should be okay. We'll see when we finish up. Okay, here we go. We've got all 4 pours here. I'll try to knock them out one at a time so I don't lose track of them. This is number 4, my size B. Number 4 is the pan down concentrates. So let's knock that one off. It's got a nice pour, no matte. Pretty big lead button, means there was still some sulfides not oxidized, but still poured nice. Pretty sticky on there. Let's see if I can knock it loose. Okay. That one's kind of sticky. I'm going to leave it there for now. Grab some glasses. Okay, that one out. Got a decent sized button. This is the ashed filter. I don't see any matte there either. That one came off nice and clean. It's like all glassy slag. So get that cleaned up better. Oh, that's we got so far. It's the ashed filter. This one is number 3, which is the tailings. Nice clean pour. No matte, which you usually don't have in the tailings assay because most everything's gone. So we'll clean that up. Keep track of those. And then this is number 1, which is just the ore. So, okay, it's no matte. Still pretty good sized button, probably because all the sulfides in it. I did not roast it. So, there we go. So we'll get all these cleaned up and weighed and stuck in the furnace. Okay, so most of these buttons turned out a little bigger than I thought. Probably a few more unoxidized sulfides in there, so it reduced more lead from the litharge. But We will start with the just head ore, 1 assay ton, 39.7 grams. Write that down, 39.7. The pan down concentrates, 21.6 grams, because I roasted that. 21.6 grams, so I'd oxidized off a few more of the sulfides. This is the tailings, 36.5, so that's interesting. There's some 36.5. There were some sulfides left in those tailings, so that's interesting. And then this is the ashed filter. This is the biggest one, 45.8. So I would guess it was probably a little bit of filter that wasn't ashed, carbon that reduced some more lead on that. So that's probably what happened there. I'll have to put that one in a bigger Capel because my small ones only handle 40 grams. So we will get that. Get the camera turned around and show you that. All right, let's get them bad boys in there. I always go left to right, 1 through 4. 1, 2, 3, and 4 in the bigger Capel. All right, put that on, about 1750 to 800, and the door crack, let it work. Okay, so I got done Capelling all these. This one's still hot, that's why it's red. They're all still a little hot. So here's the number 1, which was just the head ore, and it came out to 2.5 ounce per ton. The bead's pretty silver. This stuff averages around 70%, which would be about 1 3/4 ounce per ton of gold, but we'll just stick with total weight for now, so 2.5 ounce per ton. So here's number 2, which was the panned concentrates. I got 0.005 grams. If you multiply that by 10, or not 10, sorry, 2,000, because I did 1 pound, you come out to about 10 grams per ton, which is about triple what I've been getting on my table. So that's interesting. It's telling me I need to look closer at my table adjustments or how I'm feeding. So here's the number 3, which is the tailings, and they still assayed at 2 ounce per ton. My guess is they just got a little nugget effect. Maybe there's just a little particle of gold that dropped in there, because I doubt that's really what's in there, but definitely some loss. I mean, it's just panning, so you know, I'm not the best panner, so there's always going to be some loss. I'm not too surprised to see some loss in there. I am pleasantly surprised about 10 grams per ton, though. That's better than I've been getting. So this is the filtered panning water. So I ended up getting like 0.7 of a milligram of gold. So that's, I mean, I guess if you multiply that times 2,000, times 1, I mean, that's still pretty good. I mean, that's a bit of loss. So maybe worth looking into, like that overflow pumped out water into a tank and maybe try leaching. So that will definitely be something to look forward to. But that's the results. So it tells me I need to go back to my table, do some adjustments, and it's promising though. Maybe I can still get that gold. Stay tuned. Thanks for watching.